Hello everyone, welcome back to my channel. Today let's go over a medium that I just solved on my own. So I'm really happy about this because I was not expecting to solve this on my own, but I did after a lot of trial and error because the time constraints are quite strict here. So let's go ahead and go over it. Again, I'm going to show you my own way of doing it that I finally came up with. And so this one is called two best non-overlapping events. Basically, you're given a matrix of three elements. You have the start, the end, and the value, right? So basically you want to choose two non-overlapping events. So meaning they can't be equal. So this is non-overlapping. 4, and then if we had 2, 4, and then we had 4, 5, this is still overlapping because they have to be like, it would have to be 5, 6. They can't touch each other at all. So that's important to note. And then you want to return the maximum sum of, we're going to choose two non-overlapping intervals, right? We're just going to choose any two. So as long as they're non-overlapping, take their values and add them together and then find the biggest one that's valid. So start and end, start and end, start and end. So let's go over the brute force way of doing it, which is just to sort events by the start time. Okay, so we know this is going to be the smallest start time that appears. And then we're just going to go over events for j in range I plus 1, length of events. And then to make sure they're non-overlapping, again, if the current end time is less than, if i's end time is less than j's start time, because j is going to be bigger, at the very least, we know this is going to be bigger than this because we already sorted by start times. If events of I of 1 is less than events of j of 0, then we don't have an overlap. So then we can say, keep track of the biggest, I2, the value of I plus the value of j. Pretty simple. And then just return result at the end. So obviously this is going to be too slow. So events.sort I1 has to be less than J0. Okay, let's sort by, let's just print events. Okay, so if I0 has to be, well, let's just say if events J0 is bigger than events of I of 1, or if events of I of 0 is bigger than events of j of 1, same thing. So I don't know why this is not correct, but basically, let's see here, this is still 4. So if I0 is bigger than J1, I0, J1, let's print events of I and events of J. This is not, this is. Let's see here. Oh, result has to be, is going to at least be the maximum of a single event because it can't overlap with itself, right? So E in events, result is max of result and E2, which is the biggest value we can find, the biggest index 2 value out of all the inputs. And then this technically will work, although it's n squared, but we obviously have to find a better way of doing this. This is n squared plus, yeah, it's n squared. Sorting is log time, log of n time. So time limit exceeded. Obviously, that's not going to work. You'll get to, I think, like 40 test cases by doing it this way. So let me go ahead and show you my workaround to this, which is, okay. So basically, what we're going to do is still keep this, right? Because the result has to at least be what the biggest value that we can ever find at the very least. But now we're going to actually sort by the start time, and then the end time, and then the value. Okay, so what this is going to do is make it easier to identify the start and the end times. And basically what we want to do is keep track of all the start times, because what we're going to do is use a binary search, right? If the current start time is 4, then we are going to basically discard every single start time that is less than 4, because start time is the start time. We can't have start time of 3 if we're looking for start time of 4. So then we're not going to care about those values. We only care about the values that have at least 4 or bigger, right? And then those are the values we're going to keep track of, if that makes sense. And so what we're going to do is call this starts.append. The ordering is the same. And then we're going to go over this again, events. And so this is where we're going to, because we're already sorted by the start time. If you go ahead and look at what it looks like. Okay, so let's take this. You can see the start time is already sorted. So then we can look for a start time that's, for example, if we're looking for start time 2, we don't care about this. If we're looking for start time 4, then we can discard this, which saves us some time. And we're going to use that because we're going to binary search on the starts, which is going to be 1, 2, and 4, right? So we're going to binary search on that. And basically we're going to look for, we're going to binary search the current end time on starts, because the current end time will tell us the earliest moment that we can start at. For example, if we have an end time of 4, then we're going to be looking at these two strictly, right? So if you print this out and play with it a little bit, it'll make more sense. So b equals to bisect left inside of starts, and we want events I of 1, which is the current end. And then what we want to do is also keep track of the values. So values.append E2. So then, okay, this is where it gets a little tricky, because we're going to say length of events if n minus b is bigger than or equal to 1. And the reason for this is because if we binary search and we like out of bounds here, then we're not going to search anything. So the key is we're going to search everything to the right, because we're looking at the current end time and we want to see a start time that, at the very least, we're looking at the current end time that starts after the current end time. We're looking for a start time that ends after the current end time. So we're going to use bisect right, because that includes it like excludes anything that's literally the same. So if this is the end time and we see a start time, this is going to exclude it. It's only going to include it like this. So if this is it, then we can say result equals max of result of events of I of 2, which is the current value, plus maximum of values of b to the end, right? So that's technically going to work. And just to make this easier, let's go ahead and print events of I, and let's also print values of b to the end so you can visualize this easier. Or let's just say events of b to the end, so you'll see what I'm talking about. It's kind of hard to explain, but basically right now you can see that. Let's go ahead and get rid of this. Okay, this is why we have this check, but basically our current end time is this, right? We're going to binary search on everything only that has start time that's bigger than our current end time. That's what it does. So here, for example, same thing. For here, we're only looking for things that have a start time that's bigger than our current end time, because this is events, right? This is events of I, the current sublist that we're on, right? And then after that, then we can search everything from here, and we want the maximum of the values for example, if we're looking for this sublist, then we go for 5 because that's the biggest value that we can find. So index 2, and that makes it a little more tricky. So let's submit this. It's not going to work because this is still a little bit too slow. So I came up with another trick, which I'm going to show you. Okay, 48 out of 64. It's technically, this is n log n, but it's not going to work. And what we're going to do is, first of all, let's print out values. So we have values, and what you'll notice is that we're trying to search for something that's everything to the right because we already sorted from the start time. So if the current start time we're looking for, we're going to look from the current point to the end of the array. So that's going to make our job a lot easier because basically what you can do is go from the end and then keep track of the largest value you've seen so far, so we don't have to do maximum because this is costing us time complexity. So let's call this BB, and let's go, actually what we're going to do is go from V in vals -1, and then cur is 0, right? Cur is max of cur and V, and print current. I'll show you what this does, but basically it says up to this point from the rear, what's the biggest we've seen so far? 2. Okay, up to this point it's 3. Up to this point it's still 3. And so what we're going to do is we're going to say bb.append current. And so let's print bb. Cool. So what that's going to do is, because we're going to binary search on events of I to the end, we're going to want the maximum of like this portion. How do we find the maximum of a particular subarray? And that's the challenging part. Basically now we're going to say we want this subarray. Okay, but that's flipped around because that's this section here, right? Maximum up to this point, maximum up to this point. Going like this is going like this. So basically if we have our B, we're going to say maximum, or the current is just going to be BB of whatever the difference is, because for example, if we want this, then it's going to be the length of events minus the current index. So that's why we have n. The difference is going to be n minus b. And then we're just going to say everything up to difference. And then we're just going to say a of -1. So that makes it a lot easier, because if you print a now, and then you also print whatever we had before, which is vals of b to the end, what you'll see is that, okay, let's see here. So that's going to give you the maximum of whatever you need at the current point because of this nifty trick. So let's get rid of this. And there you go, passes all test cases. So yeah, it does take a little creativity and a little playing around with it, but you can make it work at the end. Again, we're just trying to get the maximum. Let's say we have an unsorted subarray and we want to get the maximum of this one. Then we're just going to, because we know that from the current B, we're going to go all the way to the right. We're going to start from here. 2 is the biggest, 2 is the biggest, 2 is the biggest, 2 is the biggest, 2 is the biggest. So 2, 2, 2, 2, 2. If we want this subarray, then we're just going to say 1, 2, 3, 1, 2, 3, and the biggest is going to be -1. So hopefully that made a little bit of sense. It's a little confusing, but you just kind of have to be a little creative there, and that's going to be it for this video. And so thank you for watching, and stay tuned for more.